let's go over this problem. 2 dice are rolled. What's the probability the sum of the numbers rolled is a 6? So we have, let's just list out all the possible cases. You can have 1 and 5, 2 and 4, 3 and 3, 4 and 2, 5 and 1. And this can't be any higher than 5 because then we won't have a possible outcome that works. So this is at five ways. And as we calculated in the previous class, there are 36 possible outcomes of 2 dice. So our probability is just 5 over 36. Okay, so then let's move on to the next problem. A fair coin is rolled 3 times. What's the probability there will be at least 2 consecutive heads? Okay, so you might see the word at least, and this typically means you should probably use complementary counting. But in this case, if you see, direct casework is actually easier than complementary counting. So let's use that instead. So in order to be at least 2 consecutive heads, we can either have 3 heads. And if we have 3 heads, this is basically H, H, H. And this, of course, works. So there's one way for this case. And now we can also have 2 heads. But the key thing to note here is that not all of these cases actually work. So the 2 possibilities are HHT or THH. So there's actually 2. And the reason that the third case doesn't work, like originally it would just be 3, the third case is when the tail's in the middle. Then they're not 2 consecutive heads, so this does not work. So there are 2 cases for this. So we sum, we get 3 cases. Okay, so now let's find how many ways are there to roll 3 dice. Sorry, not 3 dice, 3 coins. So we have 2 choices for each of the 3 coins. So it's just going to be 2 times 2 times 2, which is 8. So our probability is just 3 eighths. Okay, so now let's move on to the next problem. A fair 6-sided die is rolled twice. What's the probability the first number will be greater than the second number? Okay, so let's write out all 6 numbers. We have 1, 2, 3, 4, 5, and 6. So we can list them out, but that would be much harder. So we're asking for the probability the first number is greater than the second number. So what happens when you choose any 2 numbers? Let's say 1 and 3. Let's say we choose 1 and 3. Then in order to have something that works, we must have that the 3 is the first number because it has to be greater than the second number. So this has to be the second number. But if you chose like 2 and 4, 2 and 5, or something like that, in this case, so no matter what we choose, the larger number will always have to be the first dice, and the smallest number will have to be the second dice. So therefore, anytime we choose 2 random numbers from out of these 6 numbers that are different, we can always designate one to be greater than the other. So therefore, there are 6 choose 2 ways that actually work, because we can just choose any 2 of them, and then we can designate one to be greater than the other, and we can make the greater one the first die. And therefore, 6 choose 2. Okay, so here's like a trick that comes up often. You don't actually have to use the formula. So whenever you're evaluating something choose 2, you just take the product of the number times the one number less than it, so 6 times 5, and you divide by 2. So instead of doing the formula for the special choose 2 case, you can do it a lot faster. So just 6 times 5 divided by 2, which is 30 divided by 2, which is 15. So there are 15 ways of actually selecting 2 numbers. So our probability is just going to be 15 by 36, which simplifies to 5/12. So now let's move on to number 4. On a beach with 50 people wearing sunglasses and 35 people wearing caps. Some people are wearing both sunglasses and caps. If one of the people wearing a cap is selected at random, the probability the person is also wearing sunglasses is 2/5. If instead someone wearing sunglasses is selected at random, what's the probability the person is also wearing a cap? Okay, so this seems like a complicated problem. We have a lot of information and we don't really know what to do with it. So let's first use our condition here that the probability is 2/5. So we're given that any person wearing a cap, the probability also wear sunglasses is 2/5. So we have that 35 people are wearing caps, So 2/5 of them are also wearing sunglasses. So how many people are wearing both caps and sunglasses? This is just 14. And now the problem asks us, what's the probability that this person also wears a cap? So what's the probability somebody wearing sunglasses also wears a cap? So we're trying to find the probability that somebody wears both sunglasses and cap, divided by the number of ways of just having a cap. So how many ways are there to have sunglasses and caps? Well, we already calculated here that 14 people wear both sunglasses and caps, so 14. And now, how many people wear caps? Well, how many people with sunglasses? So that would just be 50. So this is just 14 over 50, which if you simplify it, is 7 over 25. And that's our answer for this problem right here. Let's move on to number 5. Two different numbers are randomly selected from the set -1, -2, -1, 0, 3, 4, and 5, and are multiplied together. What's the probability the product is 0? Okay, so we're given some numbers here, and we're asked to find the probability the product is 0. So there's a special fact about the product being 0. One of the numbers, at least one of the numbers has to be a 0. And if none of the numbers are a 0, then the product will not be 0. So let's try using complementary counting here, because we see that it's really easy to count the number of ways where none of the numbers chosen are 0. Okay, so how many ways are there to choose numbers such that none of the numbers are 0? Well, we have 5 numbers that are not 0. So we can just choose 2 of them and multiply them together. 5 choose 2. And by using the same trick, 5 times 4 divided by 2, which is 10. Okay, so now we divide by the total number of cases. So how many ways are there to choose 2 numbers out of these 6 numbers, including the 0, and multiply them together? That's just 6 choose 2. This is 6 times 5 by 2. 15, which is 15. So we use complementary counting. So how many ways are there that a product is 0? So there are 15 ways to choose 2 numbers and find the product of them, and 10 ways where it's not 0. So there are 5 ways when it is 0. And then we're finding probability, so we divide by the total number of cases, which is 15. So this is equal to 1/3. Okay, so now let's move on to number 6. Peter, Emma, and Kyler played chess with each other. Peter won 4 games, lost 2 games. Emma won 3 games and lost 3 games. If Kyler lost 3 games, how many games did he win? Okay, so the key idea in this problem is noticing that the number of wins has to be equal to the number of losses. So how many total wins are there? Well, Peter won 4 games, Emma won 3 games, and Kyler, we don't really know how many games he won, so let's just call it X. And now let's calculate the total number of losses. We know Peter lost 2 games, Emma lost 3 games, and Kyler lost 3 games. Now we can simplify this equation. We get 7 plus X equal to 8. And that means X equal to 1. So he won 1 game. Any questions on the homework before we move on to today's topic?
Why did the number of wins have to be the number of losses?
Can you repeat that?
Why does the number of wins to be equal to the number of losses?
Because each game has 1 win and 1 loss. So in every game, there's 1 win that comes out of it and 1 loss that comes out of it. So therefore, the number of wins has to be equal to the number of losses.
Oh, okay.
Okay, so now let's move on to today's topic, number theory. So over these next few weeks, we're going to be talking about number theory. So let's start off with the basics, primes. Primes are numbers that only have 2 factors, 1 and itself. So some examples of primes are 3, 5, 7, 11, 13, 17, 19, etc. And 2 is also prime. And a special note here is that 1 is not a prime. This is because it only has 1 factor, 1, and 2 is only even prime. So this is something special that we should always keep in mind. So now let's move on to a slightly more difficult problem with this concept in mind. Sum of 2 prime numbers is 85. What's the product of these 2 prime numbers? Okay, so we have that basically try solving this problem on your own. So we're given that the sum of 2 prime numbers is 85. So the key, here's a hint to get you started on this problem. So the special property of this sum here is that it's odd. So the sum is odd. But as you know, most prime numbers are odd, most. So if we take a sum of an odd number, odd prime number, and an odd prime number, we get an even number. Okay, so essentially what this means is that if we have two odd primes, the sum is even. So try to use that to solve this problem. Okay, it looks like some of you are getting the correct answer. So let's see what actually is going on here. So most prime numbers are odd. So if we have two odd prime numbers, then the sum is even. But 85 is odd, so we can't sum two odd prime numbers. But now, what if we take the sum of an odd and even number? Then the sum is odd. So in order to get our sum to be odd, we need to have one number be even, one number be odd. And as we mentioned earlier, 2 is the only even prime. So this has to be 2. So then what has to be our other prime number in order for the sum to be 85? It has to be 83. Because 83 plus 2 is equal to 85. And you can check for yourself that 83 is indeed prime. So our answer would just be the product of 83 and 2, which is 166. Any questions? Okay, let's move on to the next problem. 3 members of the Euclid Middle School girls softball team had the following conversation. Ashley said, I just realized that all our uniform digits are 2-digit prime numbers. Brittany says, and the sum of your 2 uniform numbers is the date of my birthday earlier this month. And then Caitlin says, that's funny, the sum of your 2 uniform numbers is the date of my birthday later this month. And Ashley says, and the sum of your 2 uniform numbers is today's date. And so we're asked to find what Caitlin's number is. Okay, so this seems like a lot. We're asked a conversation, so let's see if we can break this down and see what we actually have. So firstly, let's look at the condition that all of them are 2-digit prime numbers. So it's saying that the sum of 2 prime numbers less than 31 is going to be the date. And obviously that 31 is the maximum day in a month. So because there's a max 31 days in a month. So therefore, all our sums, the date of the birthday earlier this month, the later this month, and today's date, they all have to be less than or equal to 31 because that's the date. And if the date are less than or equal to 31, the individual components, we're given that the sum of 2 uniform numbers is 31 or less than 31. So each of the uniform numbers has to also be less than 31. And since they're all 2-digit primes, let's list out all the 2-digit primes less than 31. There are 11, 13, 17, 19, 23, 29. So these are the 2-digit primes less than or equal to 31. Okay, so now let's look at our conditions here. So if we take the sum of anything greater, so let's just say we take the sum of like 19 and 11. That would work, but that would not. So essentially we have to take 3 numbers, like let's just call them A, B, and C. We have to take 3 numbers such that A plus B, A plus C, and B plus C are all less than or equal to 31. So all these 3 terms have to be less than or equal to 31. So if you see that, if you take any number that's 19 or more, let's say we took like 19, 11, and 13. If you took 11, 13, and 19, then the sum 19 plus 13 would be greater than 31. And that's not allowed. So basically all the pairwise sums, all the sums of 2 numbers, they all have to be less than 31. So if we have 19 as any of our numbers, then the sum 19 plus 13 is going to be greater than 31. So therefore we can't have 19 or anything greater than 19 as well. Since if we have anything greater than 19, adding it to another prime number, even the smallest prime number, will cause it to be greater than 31. So therefore, our numbers must all be 11, 13, and 17. So these are three numbers of the three people, but we don't know who has who number, who has which number. So let's try to figure out what's going on. So we're given that Brittany says the sum of their two uniform numbers. So A plus C is going to be the date of the month, date earlier this month. So the date earlier this month. And Brittany says the sum of your, and Ashley says, and yeah, sorry, Caitlin says that the sum of your two uniform numbers, or A plus B, is the date later this month. So date later. And Ashley says sum of Brittany's and Caitlin's number is equal to date today. Okay, so we're given that these three conditions. So since the date later, we have these three numbers over here, as these have to be the date earlier, date later, and the date today. And we're given that the date later has to be greater than the date today, and the date today has to be greater than the date earlier. So therefore we know the date later has to be 17, the date today has to be 13, and the date earlier has to be 11. Okay, so now we know these three conditions. So we're asked to find what number Caitlin wears. Okay, so now we're given these three conditions. Now that we have to have the date later be the sum of the two largest prime numbers. So this must be the sum of 17 plus 13. And the date today is the sum of the two middle prime numbers, the other ones. And the date earlier is going to be 11 plus 17, these two prime numbers. And therefore, these must be 28, and the date later is going to be 30. And the date today, well, that's just going to be sum of the two prime numbers that make up the date today. So now we have these conditions. So let's see what we can do from here. So the date earlier, we have three prime numbers as all three of them. And the date earlier has to become the two minimal ones. So this should actually be that. This should be 11 plus 13. The date later will be some of the greatest ones. And the date today, well, that will just be the sum of B plus C. We don't really know what it is yet, so let's not fill it in. So we know the date earlier is 24. The date later is going to be 20. The date later is going to be, today is going to be 28, and the date today is going to be 30. So now we have these three conditions, and this must be 11 plus 17 in order for it to be 28. Okay, so now we have these three conditions. We need to find what number Caitlin wears. So we know that A's and B's number will be 13 and 17. So the only number left out is 11. So 11 is Caitlin's number. And that's our final answer. So just to clarify a little bit here, I know it's a bit confusing. So the date earlier is going to have to be less than the date today, which has to be less than the date later. So we have these three numbers, and now we can just form the conditions. The date later will be 13 plus 17. The date today is 11 plus 17. And the date earlier will be 11 plus 13. Because we have to have these conditions that this is the least, this is the middle, and this has to be the most. And then we can find the date later was 30, the date earlier was 24, and the date today was 28. And now we're asked to find Caitlin's number. So we just look at the two numbers of Ashley and Brittany, which are 13 and 17 from this over here. So therefore, Caitlin's number has to be the other number, which has to be 11. Any questions? Okay, so let's move on to this next problem. So now we're going to talk about prime factorization. Prime factorization is a way to express a number as the product of its primes. 21 is 3 times 7. 60 is 2 squared times 3 times 5. So you might already know this, but let's just quickly go over it. So let's just go over it with a quick example. What's the prime factorization of 420? So let's just break it up. So 420, so 2 is a prime, so we divide by 2, we get 210. And just keep dividing, divide by 2 again, we get 105. And now 105, we know it's divisible by 3. We're going to learn the divisibility rule for 3 later. So just this is divisible by 3. So after dividing by 3, we get 35. And we know 35 is divisible by 5. So 35 divided by 5 is 7. So our prime factorization is just going to be this part over here, which is 2 squared times 3 times 5 times 7. This is our answer. Any questions? Okay, let's move on then. So what's the prime factorization of 1001? So at first, after some experimentation, you may think this is prime, but it actually isn't. And it's a prime factorization that comes up pretty often on the AMCA. So you should probably just memorize it. 1001 is equal to 7 times 11 times 13. And you can check for yourself that this is indeed true. So this is something you should just memorize because it's really hard to actually come up with. So just memorize this prime factorization because it may come up. Any questions on this? Okay, let's move on then to a problem from the 2011 AMCA. What's the sum of the prime factors of 2010? So let's find the prime factorization of 2010. So let's just break it up into 2 times 1005. Now we easily see that 5 is a factor, so let's just do 5. And then 201. And then from here, as we'll learn later, the divisibility trick for 3, we find this is divisible by 3, and you can divide out and get that is 67. So these are our prime factors. And the problem asks us to find the sum of the prime factors. So we just do 2 plus 3 plus 5 plus 67, which is 77. Any questions? Okay, let's move on. So there's a special trick to finding the number of factors of a number. Okay, so let's look at this problem. How many positive factors does the number 12 have? Okay, so one way of doing this is just to list them all out. So we can have 1 and 12, 2 and 6, and 3 and 4. So this gives us 6 factors. But there's an easier way of doing this. So let's look at the prime factorization of 12. 12 is equal to 2 squared times 3. So let's try using this to actually find out how many factors it has. So let's look at the possibilities for the prime factor here. So when we're choosing a factor, when we're choosing the factor of 2, what exponent we have for that? We can either have 2 to the 0, 2 to the 1, or 2 to the 2. Because it has to be a factor of this. And for the factor of 3, well, 3 is just 3 to the 1, so we can have 3 to the 0 or 3 to the 1. So now we have the possibilities for 2, for the prime factor 2, and the possibilities for the prime factor 3. So let's see what prime factors we actually have. So for one factor is 2 to 0 times 3 to 0. Another factor, which is this. Another factor is 2 to 0 times 3 to the 1. Another factor is 2 to the 1 times 3 to the 0. Another factor is 2 to the 1 times 3 to the 1. And we can also have 2 to the 2 times 3 to the O. Or we could have 2 to the 2 times 3 to the 1. And we get that there are a total of 6 factors, just like earlier. And note that we didn't have to write all these factors out. I was just doing it for the purpose of explaining. But instead, we could just do that. We have 3 choices for the factor of 2, and 2 choices for the factor of 3. So it would just be 3 times 2, which is 6. Any questions on this trick?
How is this easier than using a usual method?
I just listed them all out for the purpose of explaining, but instead of doing, we didn't actually have to do all this. We didn't have to actually do this. You can instead just do three factors of 2 that are possible, 2 to the 0, 2 to the 1, 2 to the 2, and 2 factors of 3 possible, 3 to the 0 or 3 to the 1. So really, we didn't have to do all this over there. We can just do 3 times 2, which is 6.
Okay.
So now we'll move on to general formula. So a number with the prime factorization, p1 to the power of e1 times p2 to the e2 times dot 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 all the way till pk to the ek, this right here, has e1 plus 1 times e2 plus 1 dot 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 all the way till ek plus 1 factors. Okay, so don't worry about this complicated definition here. That's just stating it formally. So essentially what you have to do is find the number of factors of a number, first find the prime factorization, then all you have to do is add 1 to all the exponents, and then just multiply them. Okay, so let's look at a quick example to demonstrate this. How many positive factors does 48 have? So what's the prime factorization of 48? 48, well, is equal to 2 to the 4 times 3. So now we've completed step number 1. Now let's look at step number 2. Add 1 to all the exponents. So the exponent of 2 is 4, so 4 plus 1. And the exponent of 3 is 1. So 1 plus 1. And this is equal to 5 times 2, which is 10. So 10 is our answer. And of course, that would have been a lot harder if you just listed them all out. Okay, so now let's look at a real AMC 8 problem that uses this concept. How many positive factors does 2, 3, 2, 3, 2 have? Okay, so this would be extremely hard to list out. You probably would make a mistake, and you would almost definitely get this one wrong if you just tried listing them all out. So let's try using our clever factor trick to this large number over here. So we have that 2, 3, 2, 3, 2. So divide by 2, we can divide by 2, we get that. This is equal to 1, 1, 3. If you divide by 2, essentially what we're doing is we can just divide by 2 because we take out a factor of 2. So after dividing by 2, we get that this is just equal to 1, 1, and equal plus 366. So 11366. And then we divide by another factor of 2, and this gives us 5, 5, 4, 3, 3. And that's, sorry, wrong. So we can just divide by 2 here, and we get that a quick way to do this is 11,366 divided by 2. 11,000 divided by 2 is 5,500, and 366 divided by 2 is 183. So if you add them all up, you get 5683. And we divide by another 2. Now we can't divide by 2 anymore, actually. So now let's look at the other prime factors you could possibly have here. Okay, so firstly, wait, this might be.
When I checked, it said that 23232 divided by 2 is equal to 11616.
Sorry, I think I might have made a mistake there. Yeah, yeah. So this should be 232 11616. Yeah. So then we can divide by another 2. We get, and now we use the same trick. 11,000 divided by 2 is 5,500, and then we can add 308. So that's 5808. And now we can keep dividing by 2. 2,904. 2. 1,452. And we can keep dividing by 2 like in the same way. And this is a bit tedious, so you can just keep doing this. And 121. And 121 is just 11 squared, so 11 times 11. Now let's combine all this into a prime factorization form. So we have 1, 2, 3, 4, 5, 6 factors of 2, 1 factor of 3, and 2 factors of 11. Okay, so now let's use our factor trick. Now we have a prime factorization. We're done with step 1. So now add 1 to all exponents. This is essentially 3 to 1. So what's 6 plus 1 essentially? Times 1 plus 1 times 2 plus 1, which is 7 times 2 times 3, which is 42. And that would have been really hard to actually write out all of them. So that's why this trick is handy. Any questions on this before we move on? Okay, so now let's look at some divisibility rules. So for divisibility rule for 2, it's just look at the last digit, if it's even or not. So for 362, the last digit is 2, so of course it's divisible by 2. Okay, so that was a simple one. I'll move on to a more complicated one. For 3, the sum of its digits has to be divisible by 3. So for 972, for example, 9 plus 7 plus 2 is 18. And we can take this step even further. We can do 1 plus 8, which is 9. And this is divisible by 3, so this works. And this is divisible by 3, this whole number here. Okay, so now for divisible by 4, we just look at the last 2 digits. So for example, 172947, ignore all this part over here, just look at the last 2 digits. And is 47 divisible by 4? No, so this is not divisible by 4. Now what about 10764? You can ignore all these digits, look at the last 2 digits. 64, yes, it is divisible by 4. It's 4 times 16. So this is divisible by 4. Any questions on these 3 tricks right here? Okay, so let's move on then. Now for 5, we just look whether the last digit is 0 or 5. So 375 is divisible because the last digit is 5. And 140 is as well, because the last digit is 0. Now for 6. So in order for it to be divisible by 6, it has to be divisible by both 2 and 3. So let's try this here. 196. Well, since the last digit is 6, it's divisible by 2. But now what about 3? So 1 plus 9 plus 6 equal to 16. And we can do the further. 1 plus 6 is 7. And is 7 divisible by 3? No. So even though it's divisible by 2, it's not divisible by 3. So in order for it to be divisible by 6, it has to be divisible by both of them. So this doesn't work. Now what about 252? Well, it's clearly even. So now let's check if it's divisible by 3. So 2 plus 5 plus 2 is equal to 9. And 9 is divisible by 3. And since it's divisible by both 2 and 3, it's divisible by 6 as well. Any questions on these two tricks here? Okay, then let's move on. So 7 is a tricky one here. So 7, essentially what you have to do is take out factors of 7 until you reach a small number that's either divisible or not divisible by 7. So this, let's just see this trick because it seems a bit hard to dive into it first. So we have 240. So let's take out a factor of 7. So what's the most obvious big factor of 7 we can take out? 2,100. It's equal to 7 times 300. We can take out 2,100 and we get 140 left. And 140 we can subtract again because we know 140 is 7 times 20. And we're left with 0. So now we know 0 is divisible by 7, so our number is as well. Let's look at a more tricky example. What about 28,146? So obviously we can take out 28,000 because it's like a clear factor. This is 7 times 4,000. And we're left with 146. And you can take out 140, which is 7 times 20. And we're left with 6. And 6 is not divisible by 7. So this whole number isn't divisible by 7 either. So any questions on this trick here? And note that this trick also works for other numbers, but for other numbers, there's typically easier tricks. So this is like, since 7, there's no easy trick, we're just gonna use this trick for 7. Okay, so now let's move on to the next divisibility tricks here, 8. So in order for it to be divisible by 8, the last 3 digits have to be divisible by 8. So in this number over here, ignore 423 and 824. And now we can use the same trick that we used for 7 because we've already narrowed down the 423. We don't really care about that anymore. But now we still have to figure out whether 824 is divisible by 8 or not. So let's subtract off 800 because we know 800 is 8 times 100. Oops, sorry. And then we get 24 and we can subtract. And 24 is clearly divisible by 8, so this works. Now what about 4827676? Ignore these digits over here. 676. Okay, so 676. Let's subtract off 640 because we know 640 is 8 times 80. We get 36. And 36 is not divisible by 8. So this doesn't work. It's not divisible by 8. Any questions on this trick?
Yeah.
Let's move on then. For 9, the sum of its digits has to be divisible by 9. So for example, 63198. 6 plus 3 plus 1 plus 9 plus 8. This is just 27. And 27 we can do further. 2 plus 7 is 9. And 9 is divisible by 9, so this does work. Now what about 815419? We do 8 plus 1 plus 5 plus 4 plus 1 plus 9. We get that's equal to, well, we can do 8 plus 1 is 9, 9 plus 5 is 14, 14 plus 4 is 18, 18 plus 1 is 19, and 19 plus 9 is 28. And we can do further, 2 plus 8 is 10. And 10 is not divisible by 9, so this doesn't work. Now 10 is obvious, the last digit has to be 0. I'm sure all of you already know this trick here. Any questions on this trick here? Let's move on then. So this is a tricky one. So in order for it to be divisible by 11, it has to be divisible by, basically we have to look at the sum of the alternating digits. So essentially we have to calculate the sum of the odd digits, sum of the even digits, and then if O minus E, the absolute value of that, is divisible by 11, then the number is as well. And by odd digits here, I don't mean like the digits that are odd, like 3, 3, and 1, 1. I mean like the position of the digit. So like, for example, 1, 3, 3, 1. So what are the odd digits? So the odd digits are the first digit, the third digit, and if it was bigger, it would be the fifth digit, the seventh digit, and so on. So it's 1 plus 3, that's 4. So now let's calculate the sum of the even digits. So the second digit and the fourth digit. So this would just be 3 plus 1, which is also 4. And our formula says to do O minus E. So we have to find 4 minus 4, absolute value of this. So this is just 0, and 0 is divisible by 11. So this is divisible by 11 total as well. So now what about 6, 1, 9, 3? Same trick here. 6 and 9 are the odd digits, and 1 and 3 are the even digits. So the odd digit sum is 6 plus 9, 15. The even digit sum is 1 plus 3, which is 4. And now we do this, the same formula here. 15 minus 4, which is 11. And 11 is divisible by 7. And you might be wondering why we have this absolute value here. This is because sometimes this might be negative, so we should always take the positive value of that and check if it's divisible by 11. So any questions on this trick? This is like the most advanced trick, so slightly tricky. Okay, let's move on then. So for 12, it has to be divisible by about 3 and 4. So this is pretty easy to check. 1584. So for 4, we can ignore these two digits. We have that 84 is divisible by 4. So for 4, it's yes. Now what about for 3? For 3, we check 1 plus 5 plus 8 plus 4. And this, if you find the sum, is 18. And 18, you can add it further. 1 plus 8 is 9. And 9 is divisible by 3. So it's divisible by both 3 and 4. So it's divisible by 12 as well. Now what about 230792? Ignore these digits, last two digits. Well, 92 is divisible by 4. And if you don't see why, you can use the same trick. Minus 80 and it's equal to 12. And 12 is divisible by 4. So 92 is divisible by 4. So the whole number is 2. Now what about 3? So 2 plus 3 plus 0, which is nothing. So 7 plus 9 plus 2. And if you add this up, you get that's equal to 23. And you can add it further if you want. This 3 is 5. So it's not divisible by 3. And since it's divisible by 4 but not 3, it's not divisible by 12. Okay, so any questions? Now let's move on to 15. So for this, it has to be divisible by about 3 and 5. So let's look at this number here. So for 5, it's clearly divisible by 5, of course. Now what about 3? 3 plus 5, 2 plus 3 plus 5. What is this? Well, you can add it, it's 18. And you can add it further, 1 plus 8 is 9. And 9 is divisible by 3. So the whole number is divisible by 15. Since it's divisible by about 3 and 5. Now what about 374,740? Well, it's divisible by 5 clearly because the last digit is 0. Now what about 3? So we have 3 plus 7 plus 4 plus 7 plus 4. And we can add this up, we get that it's 25. And 25 isn't divisible by 3. So even though it's divisible by 5, it's not divisible by 3. So this doesn't work here.
Why do we skip a few numbers?
Because they don't really come very often. Like we skip 13 and 14. Like these are the common ones that you have to find. Beyond that, if you get, find the remainder divided by 13, then it would just be easier to divide. There's no really good trick for it. So these are the ones that come up most commonly. That's why.
Okay.
Okay, so now let's move on. Any questions first? Let's move on then. Okay, so here's the problem. The 5-digit number 2018U is divisible by 9. What's the remainder when it's divided by 8? Okay, so try to solve this problem on your own. So the key trick here is to use the divisibility rule for 9 to find out what U is. And then after that, now use the divisibility trick for 8 to find out whether it's divisible, what the remainder is, essentially. So first, the first step is to find U. Then after you find U, try to see when it's divisible by 8. If you have any questions, you can ask me.
We can't hear you.
Sorry,
You're on
I
mute.
made it so again. Sorry. Let me re-explain that. So the 5-digit number, we have to find the sum of the digits such that it's divisible by 9. So when will it be divisible by 9? Well, let's look at what values of u will work. So we have to have that 2 plus 1 plus 8 plus u. This has to either be like a multiple of 9. So it can be 9 or 18. Or if it's anything bigger, like it was 27, then we would have that u will not satisfy it, because then we wouldn't have a large enough value of u that works. So anything past 29 won't work. So now the two possibilities are 9 and 18. And you can check that 9 also doesn't work, because this is 11 plus u, and that would mean u to be negative, and that's not possible. So now we have that 11 plus u is equal to 18. The u has to be 7. So now we have a number, 20187. So now we look at the last 3 digits. We don't care about these 2 digits. 187. So let's do the same trick. We subtract 160. This is equal to 8 times 20. We get 27. And we can subtract 24. This is 8 times 3. And now we get a remainder of 3. So 3 is our answer. Any questions? So remember, the key idea to this problem was finding, like, we see an unknown. So let's just try to figure out what it is based on this condition here. And then now after that, it just becomes a simple application of the divisibility rule. Okay, so then let's move on. So the 7-digit numbers 74A52B1 and 326AB4C are each multiples of 3. So we're asked to find what could be the value of C. So again, the key thing here is to do is look, okay, what are the possible values for A and B? What are the possible values for A, B, and C? And try to narrow down our variables here. So we have 3 variables, try to reduce it down and see if you can actually evaluate the value of C. So try to work on this problem for a minute or two. Okay, so I think this thing's probably, let me just give a small hint here. So that means we have, since it's divisible by 3, we must have 7 plus 4 plus A plus 5 plus 2 plus B plus 1, and 3 plus 2 plus 6 plus A plus B plus 4 C. Okay, so we can, so hint is simplify these expressions, and we'll get like a something plus something. So let me simplify it actually. So we can get that 7 plus 4 is 11, 11 plus 5 is 16, 16 plus 2 is 18, and 18 plus 1 is 19. So 19 plus A plus B. And now we have here 3 plus 2 plus 6. So 3 plus 2 is 5, 5 plus 6 is 11, and 11 plus 4 is 15. So this is 15 plus A plus B plus C. So the key thing to notice here is that if these are both multiples of 3, the difference will also be a multiple of 3. So what happens when you take this right here minus this? So what happens when you subtract them out? So that's a hint. So what happens when you do 15 plus A plus B plus C minus 19 plus A plus B? Then that will also have to be a multiple of 3, right? Because we're subtracting 2 multiples of 3. So, and then you can try to use that there and try to move on from there. So try to use that hint that I just gave you and see if that will help. Because now we've eliminated 2 variables, A and B. So I think let's move on. So let's move on. So now I'm going to use the hint that I just gave you. So 15 plus A plus B, C, minus 19 plus A plus B. This has to be a multiple of 3. So 15 minus 19, that's negative 4. these terms will all cancel out. So we have C left, so negative 4 plus C. So we have that C minus 4 has to be a multiple of 3. So now we have option choices, so let's just test them out and see which one will work. So basically we must have C minus 4 be a multiple of 3. So we can test them all out and find that the only one that actually results in it being a multiple of 3 is 1. So therefore our answer is A. So basically we have to find a number C that has the same remainder when 4 is divided by 3, and that's 1. So that's the answer for this problem. And this even though it seemed a bit intimidating at first, we got rid of a lot of terms because these terms all canceled. So that was something that we did, so that was useful to us. Okay then, let's move on. Sorry, if there's any questions. Are there any questions? Let's move on then. Okay, so we had the digits 1, 2, 3, 4, and 5 are each used once to write a 5-digit number PQRST. We're given that the 3-digit number PQR has to be divisible by 4, QRS has to be divisible by 5, and RST has to be divisible by 3. Wait, I got a question on the last problem. Why don't you do 19 minus 15? If you do 19 minus 15, then we get a negative C term. It would be the same thing, essentially. Then you get 4 minus C. And then you can do the same thing here. It doesn't really matter what you do. You can do either thing. But even from here, you can find that C is 1. So you can do either if you want. The thing is just subtract one from the other to eliminate the A and B terms. Okay, let's come back to this problem. So we're asked to find the value P. So try to solve this problem. And I'll give you a small hint first. So the thing is, remember, as we did in the first class, PQR has to be divisible by 4. So PQRST. So PQR has to be divisible by 4. So let's look at the most restrictive condition first, because that's usually the easiest to deal with. So PQR has to be divisible by 4, QRS 5. So which is the most restrictive? Well, clearly the QRS 5 condition. So try to look at that condition first, and then try to build your way off from here. And this is a tricky problem, so don't feel bad if you can't solve it. So I'm going to give you a 1 or 2 minutes to work on this problem. It's quite challenging, so I'll give some more hints on the way. So if you're stuck and you don't really know what to do yet, so of course let's look at QRS. So if it's divisible by 5, this is either 0 or 5. So that's like the easiest thing that we know. It's all, like, it immediately pops out to us. Now the next thing to look at is, we don't really know PQR, divisible by 4. We don't really know any of these digits, so that would be kind of hard to work with. So instead, let's look at this next condition, RST, divisible by 3 condition. So now we have to use that condition. Now we have that R plus ST has to be a multiple of 3. So let's look at the possibilities for R, S, and T. And firstly, before I even move on, it can't be 0, of course, because our digits are 1, 2, 3, 4, and 5. And they're each only used 1, so it has to be 5. That's something we immediately know. So now look at R, S, T, see what values are possible. And note that this has to be equal to a multiple of 3. So like 3, 6, 9, 12, 15, ... And many of these don't work. So see if you can try eliminating this. So now try to use this condition here to try and finish the problem. So now I'll just give you one more piece of information here. 3 doesn't work because we already have 5 term. And 6 also doesn't work. And this is because that would mean R plus T is 1. And that's not possible given that our lowest number is 1. So the sum would be at least 3. So 6 is impossible as well. So now, and we also noticed that 15 is impossible because if 15 was a sum, that would mean R plus T is 10. And we're given that the 5 and 5, R plus C have to be the maximum values here. We're given that R plus C have to be the maximum values. So if R plus C are both 5, which is not possible, so the maximum sum of R plus T would be 5 and 4 or 9. So 15 isn't possible. So now we're left with 2 cases, so 9 and 12. So now it's a little bit of casework. So let's just try both cases and see which one will actually work out. So now actually let me just explain the solution now since we're running out of time. So in order for it, we must have R plus C equal to 4. So that's one case here. And if R plus C is 4, what numbers are possible? So we could list all the possibilities, 1, 3, 2, 2, 3, 1. But the digits are distinct, so 2, 2 doesn't work. So now we have 2 subcases here. Either this 1, 3, or it can be 3, 1, which we'll see later. So it's 1, 3, then now we look at our final condition, PQR divisible by 4. But if the last digit is 1, the number itself is not even. So if it's even, it can't even be divisible by 4. So this doesn't work, this condition over here. And now let's try 3, 1. But if you try 3, 1, you'll get a very similar conclusion. It's odd again, so it's not divisible by 4. So this also doesn't work. Now we've eliminated this case. So now let's look at the case where the sum is 12. This means R plus T, 7. So now let's look at the possibilities here. 1, 6, 2, 5, or 3, 4. And the other cases are the same in the other orders, like 4, 3, 5, 2, 6, 1. And 1, 6, and 6, 1 don't work because that would mean that a number 6, which is not allowed. So now we're left with these cases over here. And just like earlier, we see that this digit right here has to be even digit. Because if it's an odd digit, then the number is odd and not a multiple of 4. So now we must have R is even. So out of all these numbers, there's only one even number that we can find, which is either 2, 2, or 4. So there's 2 cases here that we should probably look at. So now the first case, if this is 2 and 4. And then we'll tackle the, 2 and 5. And if it's 2 and 5, then how can we get PQR to be a multiple of 4? Well, that would mean QR, it has to be a multiple of 4. But we already see that there's 2, 5, so this is not allowed. So we don't even have to check this case. So 2, 5 doesn't work because that would mean there's 2 5s, and we're given that all our digits are each use 1s. So now we see the other case where R is even. The other case when R is even is when this case here. So when this is 4, this is 3. And there are no duplicates, so we're good so far. So now this is 4 and this is 3. Now what numbers do we have left? We have 1 and 2 left. So this is either 1 or 2. So we can check both cases. When will these last 2 digits be divisible by 4? So when will our PQR be divisible by 4? When QR is divisible by 4. So when will QR be divisible by 4? Either when Q is 1 or 2, and 14 is not divisible by 4, so 24 is divisible by 4. So this would actually be 2 here. And now this digit over here is just the only remaining digit, so 1. Now we've used all the digits, and as a sanity check, you could check that this actually satisfies all our properties here. So our answer is asking for P, so our answer is just 1. Any questions? This is a really tricky problem, so don't feel bad to ask questions. Okay, so then now these are your homework problems for this week. I'll put the form again, and I'll try not to do the mode where you can't enter fractions. You actually, this week you only need enter fractions, so that should be okay. So these are the homework problems. Try to do them to the best of your ability. And we'll go over them next week. Okay, bye. Thank you for coming to class.
Thank you. Bye.